You got this function defined by y equals x squared plus 3x plus 4. Y equals 0 means what? X squared plus 3x plus 4 equals 0. You understand that we can easily factor this as x plus 4 times x minus 1, right? And then we can easily see that, well, okay, so we'll say it this way, negative 4 and 1 are solutions because let's write this out correctly. Okay. Negative 4 and 1 are solutions because if you plug in negative 4 here, you're going to get a 0, right? And times this is going to give you 0. Well, I write that as negative 4 plus 4 and negative 4 minus 1. I don't seem to be able to write anything correctly, so let's fix that. I didn't bother writing negative 4 minus 1. It should be negative 5. Because whatever it is, multiplied by 0, you're going to get 0. So I just left it like this. But I didn't want to do all that arithmetic. Because, just to make the point that it doesn't matter what this is, as soon as this is 0, you're going to get 0. So, if you can factor, it's always going to work. And sometimes that's quicker, because you can factor this in pretty quickly. That's quicker than working through the quadratic formula. Also, if you've got it factored right, you have fewer chances to mess it up. Okay? Alternative. Is to use the quadratic formula. And you would get x equals, everybody work this out, let's just do this to make sure we have negative 3 plus or minus 3 squared minus 4, and everybody seems to want to use a plus there, so be careful about that. Minus 4 times a, which is 1 times c, which is 4. Over 2 times 1. That's negative 3 plus or minus the square root of 25 over 2. Negative 3 plus or minus 5 over 2. And negative 3 minus 5 is negative 8. Divided by 2, you get negative 4. Negative 3 plus 5 is 2. Divided by 2, you get 1. Same thing you get here. If you can't factor it, or if it's just too ugly to try, you can always go to the quadratic formula, right? Okay, so that's easy. Now, what's the graph of this function look like then? Well, we have a y-intercept and we have x-intercepts. Y-intercept occurs when x equals 0. This occurs when x equals 0. So y equals 0 squared plus 3 times 0 plus 4 equals 4. And the x-intercept when y equals 0. So x equals negative 4, or 1, right? Meaning that your graph passes through the point 0, 4, through the point negative 4, 0, and through the point 1, 0. The graph is a parabola because this is quadratic, okay? The graph is a parabola. Now, if you try to draw a parabola through these 3 points, well, that's not going to be the peak because it'll probably be lopsided. Try to do the peak here and then come back down here, it's not going to have a nice symmetric shape. So the parabola's got to have some symmetry, so it's going to have to go up here somewhere and then back down through here, maybe like this. That's a reasonable graph. Okay? Now, if that's the graph, here's the vertex. And here's the axis of symmetry.
What do you mean?
Well, the axis of symmetry, if this thing's symmetric, this point should be the same distance on one side as this is on the other, right? Looks like I've got a little too far to the left. Okay? And it looks like it's a little fatter on this side than it is on this side, so I probably should have put the vertex closer to here. So I maybe could have improved it by making it just a little flatter through here, maybe to come up through here, and maybe down through here. Is this better? Well, that would put the axis of symmetry here. Is this a better axis of symmetry? Yeah. If anything, this is a little closer to this point than this point, but it's closer to being halfway between these points, I think, than this one was. Okay? So you can, if you draw these, of course, then, I didn't put it quite through the vertex. The vertex would have been about here. If I'd have drawn my axis of symmetry a little closer, it probably would have been pretty good. Which is just dumb luck, but, probably would have been pretty close. Well, now you already should know, because we have done it, how you graph a quadratic function, okay? But this is either one of these would be an acceptable approximate graph. I would expect you to, maybe if you drew this and say, it looks a little too far to the left, and I'm going to say it's close enough. Okay, well, as we've seen, the actual axis of symmetry is halfway between the zeros. And to get the point halfway between the zeros, which are negative 4 and 1, you add those two and divide by 2, because that gives you, if you add two numbers and divide by 2, you get the numbers halfway in between them, always. So that'd be negative 3/2. Now if I divide this distance from 0 to negative 4 1/2, I get about this. It looks like my original axis of symmetry is pretty close to, well, actually, it's a little further over this way. Pretty close to negative 2. If negative 1 is here, then the axis of symmetry is like here, then that's about halfway. Now, just kind of reviewing what we know about how to graph a quadratic function. Now, we want to extend this. So, we want to ask what happens if you've got a polynomial. Let's just say it was y equals x plus 4 times x minus 1 so far. And then we multiply this by x plus 2. Now what's that do? Well, this graph isn't going to be a parabola anymore. Okay. How do you get the y-intercept? Well, it occurs when x equals 0. Okay. So now the 0, the y-intercept is at negative 8. Means if you want to construct this graph, your y-intercept is down here at negative 8. The zeros of the function well, you get one at negative 4, you get one at 1. And of course, if x is negative 2, you get one at 2 now. So now we've got zeros. That gives us x-intercepts. So, here's negative 4. And it's negative 1, it's negative 2. Negative 4, negative 2, and 1, right? These are our zeros. Okay. Well, if x gets really big, then this acts a lot like x cubed, doesn't it? Because if x is a really big number, if x is 1,000,000, then you got 1,000,000 for 999,999 and 1,000,002, right? Could be a little more than 1,000,000 times 1,000,000 times 1,000,000, which is really big. A little over 1 trillion, okay? Well, this means that for large x, the graph is just going to go up here and get really steep. Okay? Because you get large positive values of x if you go this way. If you got a large negative value of x, that means you're going this way. Well, if x is negative 1,000,000, well, that's practically 1,000,000. Negative 1,000,000, that's practically negative 1,000,000. That's practically negative 1,000,000, right? Which gives you negative 1 trillion. Okay? So, for large negative x, the graph goes down like this. It also has to go through this point. So if you want to draw the graph, you start way down here and come up through here. Then you got to turn around to go through here, and you got to turn around again to come through here, and then you go on up. This is not necessarily, usually will not be the low point of the graph. You just graph it between here and here in a way that makes sense, so that when you turn around, you come up here, and it's more or less symmetric when you get close to this low point. Okay, because it's more or less symmetric here. But from here to here, it's not really all that symmetric. So it's like you got this pseudo-axis of symmetry here. But if you get a little ways away from that axis, you lose the symmetry. Obviously, what happens here is non-symmetric with what happens here, right? So, well, that's how you would graph this polynomial. Now, if you expand this polynomial, you're going to get an x squared or an x cubed, and then some multiple of x squared, and some multiple of x, and just some number, right? Now I'm going to expand it. You would expand it by first do this times this, which is x squared plus 3x, x squared, yeah, plus 3x minus 4. Okay, I guess that's what you had, x squared plus 3x. Yeah, I did something really ignorant before. Let me double check. It was x squared minus 3x minus 4. So I had the wrong sign, so I wrote it down carelessly. Okay, I'm going to change this to x squared plus 3x minus 4. Just a minute now. Got to go back and correct this function. Okay, now everything I wrote is true. I don't think I've got that written down anyplace else. Okay. So I wrote this function down previously very carelessly. If I multiply this out, then I get this. Now I could multiply this by this, okay? And I would get x cubed. I multiply this by x plus 2. Then I get 2 times x squared and x times 3x, which I think would give me 5x squared. Then I'd have negative 4x, x times negative 4. And I'd also have 2 times 3x, which would be 6x. So I think that's plus 2x. And then it's going to be minus 8. Now, question mark on that, whether I actually did that right. Okay. Another way I can do that is I can look at this. If you understand this, it's probably worth going back and looking at this part of the video, thinking about it, but it's not necessary. Okay, but I'm going to do it because I can do it quickly. I got an x squared from these two, right? And that x squared will, let's say, multiply this 2 to give me a 2x squared. Okay. Then I have an x squared from these two, which has to be multiplied by 4. Okay. So I got a 4x squared along with a 2x squared. But then this one and this one give me an x squared that gets multiplied by that negative 1. So that's going to give me a negative x squared. I put that together. I get a 4x squared, a 2x squared, and a negative x squared gives me 5x squared. Now you're not going to, I think I said that fast, you're not going to remember every calculation I said, but again, if I match these two up, I've got an x squared that can multiply that too. If I match these two up, I've got an x squared that'll have to multiply that 4. And if I match these two up, I've got an x squared from these two that has to multiply that negative 1, and that's going to give me all my x squareds. And then I can see how I'm going to get x's and everything else, okay? So you don't have to be able to do that, but it can be handy. So if you understood it, you might think about it a little bit, but that's all I'm going to say about it. Okay. If you were given this, how would you get this into this form? Well, if you don't know the tricks, I'd say you're out of luck. And usually, whether you know the tricks or not, you're out of luck. Okay? So it's not something that will typically happen. You're not typically going to get a polynomial that you can factor. Still, sometimes you do, and it's worth knowing how. So, one thing you can do is you can plug numbers in for x. Easy numbers, like 1 and -1, or 2 and -2, and see if one of them happens to match. So it happens to give you 0. Well, what's the first number you would want to try? What's the easiest number you could plug in for x? 1. Okay? In this case, that works. Because if you plug in 1 here, you get 1 and 5 and 2, which is 8. Can we see that? And you subtract 8, you get 0. Okay? So, if 1 works, then it's because x minus 1 was a factor. Because, of course, if x minus 1 is a factor, it means that x equals 1 is a solution, as we have seen pretty well today. Okay? Plug in easy value of x, hope one of them gives you 0. Okay, so x minus 1 must be a factor. Well, it was. Okay? Right here it is. Yeah, I don't know how I'm going to get from here to there, but let's try it. Okay, this tells you that x minus 1 was a factor. That's how we got this. Okay? Now, you could try x equals -1, but you know that's not going to work because if it did, x plus 1 would have been a factor. The next easiest number would be 2. Plug in 2. Well, you get 8 here, and then all these are positive, so when you subtract 8, you're not going to get 0. You can see that right away. You just start, and you say, yeah, I know why that's going to be 0. So that shows me that x minus 2 wasn't a factor. And sure enough, I look back here, and x minus 2 wasn't a factor. Then you could plug in x equals minus 2. Well, that gives you -8 and 20 and -4. Okay? Now, -8 and -4 and -8 is 20. This is 20. 20 minus 20 is 0. Well, that worked because x plus 2 was a factor. Now, you don't want to keep plugging in numbers, though. Actually, in this case, you plugged in 1 and found out that it gives you 0. So x minus 1 has to be a factor. So now, I'm going to say divide by x minus 1. Now divide what? You divide the polynomial. Now, you should have seen this in some of your prerequisite courses. That's I can divide this into this. You've ever seen this? Okay. Just review it. And your book gives you, I mean, your open math, it gives you several videos that show you the process. But I'm going to say, okay, we get x squared. Multiply x squared by x minus 1, we get x cubed minus x squared. We subtract the x cubed minus x squared from this, just like you do in long division, that you've probably forgotten because I haven't used it in 100 years. Okay? But we subtract, which means that we do x cubed and negative x squared, 5x squared and positive x cubed and negative x cubed. 5x squared and positive x squared gives us 6x squared. And we bring down this 2x. And now we divide the x into 6x squared and we get plus 6x. Multiply that by the x minus 1, 6x squared minus 6x. Make a little note to change our signs. And we see that we get 8x minus 8. We divide x into 8x, we get plus 8. We multiply x by 8. Multiply 8 by x minus 1, we get 8x minus 8. We're done, there's no remainder. Okay, what does this tell us? Well, this divided into this gives you this, so that this has to be this times this. Okay? And of course, we can multiply this easily enough. Make sure we do get back to this, make sure we did it right. But x squared plus 6x plus 8 is easy to factor. And if it isn't easy to factor, we can use a quadratic formula to see what makes it 0. Well, then this is x minus 1 times x plus 4 times x plus 2. And you'll see that quickly. You factored the things that I gave you, okay? And once you got on track with that, you didn't have any trouble. And you wouldn't have had any trouble if this had been one of them. This is easier than at least one of them that everybody got, okay? So now we've rediscovered that x equals 1, x equals -4, and x equals -2 are zeros, right? So if you'd have had this but hadn't had the factored form, what would you have done? You'd have found out that 1 makes this 0, so x minus 1 has to be a factor. Then you divide x minus 1 into this. It works out evenly, as it has to if 1 is a factor. So that this equals this. And then you can find the zeros of this because it's quadratic. Turns out that it factors, so it's easy to find the zeros. If this was plus 7 here, well, you could still do it. If it was plus 5 here, factoring, no, 7 wouldn't work. Okay. If this is 7, you wouldn't be able to factor. For most numbers you put here, you can't factor. Then you can go to the quadratic formula. Quadratic formula would tell you what the zeros are. Or if this thing can even be 0. Because maybe if this is plus 20 here, your quadratic formula would give you a negative under the discriminant, and negative for the discriminant, negative under the square root. And you wouldn't have any more zeros. The only 0 would be at x equals 1. Okay? Well, that's, in a nutshell, how you find the zeros of a polynomial. Doesn't always work out. If this is an x to the 4th with x cubes and x squareds and stuff, you might find a root, but then you get a polynomial that you can't find a root for. Well, that's what usually happens in the real world, but in a pre-calculus course, it often works, okay? Okay, so, not overly difficult if you understand how the graphs come about. Now, another thing could happen. Okay, let's say you got this. It's clear that the zeros, okay, well, the y-intercept is 3. Just plug in x equals 0. X-intercepts are at 1 and negative 3. So if you want to graph this, you got x-intercept at 1, x-intercept at negative 3, and a y-intercept at 0, 3. So here are the intercepts. Now, there's a twist on this one. I'll explain to you in a minute, but we know that for large positive values of x, I'll just say large x that's greater than 0. Again, you're going to get like 1,000,000 squared times 1,000,000, which is like 1,000,000 times 1,000,000 times 1,000,000, right? If x is 1,000,000. Okay? So it's going to be really big. Much bigger than 1,000,000. Over here, so large x greater than 0 gave you a very large y here. Here, a large x is less than 0. You get a very large y that's less than 0. Okay. So it's got to start down here and end up shooting up here. Okay? Just like this one did. Okay? Shoots way down as you go to the left, shoots way up as you go to the right. When you get to the left and right of all the zeros, things very quickly get big.